All right. So, hey guys, as I got the introduction already, so not much more to add. Today I'm going to be talking about monorepos with Python. So, firstly, let's just do a quick show of hands, right? How many of you guys are using Python? Okay, good. All right. That makes sense. And how many of you guys are using monorepos? Okay. Somebody said not with Python, I heard. So I guess JavaScript or something like that. Cool, cool. So very few people. So the main thought process with this talk and also what I've been doing at my work at Corridor Platforms is just trying to understand how to structure our code. And we have a lot of, we make a lot of web development stuff. So web application stuff. So we have backend written out in Python, front end written out in JavaScript, like Angular and so on and so forth. So always been wondering why do the JavaScript community use so many monorepos and nobody at Python and backend really uses it. And that just got me started thinking into the whole thought process of, hey, can I use monorepos with Python? And that's what we're going to be talking about in this quick presentation. Just about all the experimentation and analysis that I've done about how can monorepos be used and how can they benefit for someone who works with Python, right? So first of all, let's just go into just because many of y'all don't know what or have not been using monorepos and there may be some misconceptions. Let's just talk a little about some terms that we're going to be talking about. So first of all, common misconception, monorepos don't mean that you're going to be following a monolith architecture. How many of y'all know what is a monolith architecture? All right. How many of your product managers have told you all not to use monolith architectures? So basically the thought process with monolith, it actually comes from just the concept of architecture, like literal architecture, not software architecture, goes into using a single piece of stone to build something, right? It just means rigidity. And there can be many levels of monolith, right? A lot of people just come and tell me that, hey, you're not using Docker, so you're not, so you're monolith. And that doesn't make much sense to me. You can be monolith or rigid, rather, in different layers. Your deployment could be rigid, right? You could just say, hey, I'm only going to be deploying on one machine as compared to a swarm of machines or something like that. Or your architecture and modularity may not be there in your coding practices, which could be a monolith structure of code. In monorepos, all we're going to be doing is that instead of having multiple repositories in Git or any version management system, you're going to have a single one. So you're just going to have a rigid repository structure. So just the folders are going to be rigid, right? This does not mean that you're a bad coder. This does not mean that you're not following your product manager's rules. It just means that you're using a single repo, right? That's about it. Going to polyglot, I think we've spoken about this in many conferences and so on and so forth. Polyglot is just a term used for many languages. It doesn't come up as much when you're talking about multiple repositories because you can have one repo for JavaScript, one repo for Python, etc. But typically, when you speak of monorepos, you're talking about a polyglot repo which has multiple languages. So everything we're going to be talking about right now is applicable for Python, but also for any other languages. Right? Git, I mean, no introduction needed. I guess everyone knows Git, just something to manage code. And the two terms that we're going to be talking about are polyrepos and monorepos. Polyrepos is just having multiple Git repositories, like one for project number one, a second for project number two. Monorepo means having a single repository with different folders, typically, or different areas in the repo for each of your projects that you're going to be working on. And under monorepos, there are two kinds of monorepos that people talk about, and I'll be going into this a lot more. You have integrated repositories, which we'll talk about. I'm not going to go much more, and package-based repositories. And we're going to talk about, like, the main discussion in this talk is going to be about, number one, should you be using monorepos? Should you be using polyrepos? I mean, the answer is always going to be it depends. So we'll go into what does it depend on, and which structure of monorepo should you be using, integrated or package-based, right? That's going to be the starting of this conversation at least. So things to consider, right? Now, as a maintainer of any code base, the common things that the common actions that people will be performing on it are these, right? You need to install dependencies, you need to format and make sure your coding standards are being met. You need to build the code. In Python, there's not much of building. So it's just because it's an interpreted language. So not very relevant over there. Then you need to run the code, test the code, package it into wheel files or whatever you have and then deploy it into a production environment, right? So these are the common things that you want to think through whenever you're going to be talking about changing the code structure and so on. We'll come into it a bit more. And the next question is, who are your clients? Like, who are the personas that are going to be impacted by you changing a structure from, let's say, polyrepo to monorepo or whatever it is? So in my mind, at least, you have mainly three. You have the developers who are going to be taking this code base and then running things in their local environment, making changes, cloning, editing, committing, etc. You have the CI environments, which now play a huge role in our lives because half the time you're committing something and you're waiting for CI to run for hours and hours. So CI environments, are they able to run fast? And are you making sure your code is stable? And the end user, which ideally should have no impact because here you're just changing the structure of the code, right? You're not changing any product requirements or anything of that sort. So there should ideally be no impact to your end users of your product. So the question coming up to monorepos versus not, first of all, the best resource that I found for it, and this is added in the references later on, is this particular repository by Joel Parker Henderson called Monorepo versus Polyrepo, which talks a lot about what are the benefits of monorepos, what are the benefits of polyrepos, and so on and so forth. And it has a very cool table over here, which really went through all the points that I had to think through. Like, for example, the one thing which I did not really realize as a quick example is access control, right? With polyrepos, because I have multiple Git repositories, I can choose who has access to which repo. Like if an intern joins my company, I can make sure he has very minimal access or whatever, right? So he doesn't mess up things. But in a monorepo, you actually have one repo and then access controls to that repo. So everyone has access to all the code bases in that repo. Interestingly, tools like GitHub doesn't have this, but GitLab also offers directory level permissions, like who can merge what kind of code in which directories, which is all pretty cool. But at least that's one of the things to think about, which I had not realized. And I would have probably realized that maybe 6 months after I went into my whole journey in monorepos. Other than that, you also have the main thought process of changes and collaboration, which is when you're going to be making a change in one project, do you want all the other projects to also use that change immediately or not? What that means is, let's say if I have project one and project two, can project two use an older version of project one? Or do you want it to always be tightly coupled and use the same version of project one? Right? Should all of them be at the same version? Angular is a very good example of this, which is like all the packages that you use from Angular have to be at the same version. Right? You cannot have different versions of Angular packages. And that normally comes down to like about how tightly coupled your code bases are, which also comes down to who is actually developing your project. So the basic thought process that came out when I went through this whole thing was, well, one of them is tools like Git, GitHub, etc. work only well for very medium-sized projects. You don't want to go into like very large 10 GB large projects. Hopefully you're not committing PDFs and stuff into it, but some people do. And I've seen projects which are like 1 or 2 GB, even for small repos. But ideally GitHub, etc. are good for projects which are like 500 MB, right? Anything more than that, it starts becoming a bit sluggish. There are more optimal tools which are not as popular or open source, which let's say Google and other companies use. So that it's available, but just not what we typically use. The other one was what I was talking about in terms of collaboration. Ideally, every project in the monorepo should be done or should be worked on by the same team, because that's when you have a tightly coupled set of projects, right? If you have different teams, you probably want one team to not be impacted by another team's work immediately. They should be able to use an older version of that project or whatever it is. So another principle that I kind of found as a rule of thumb was, if the same team is working on all the projects, then great, just use a monorepo. It probably makes their life easier instead of them cloning multiple repositories and so on and so forth. Which also goes into a thought process of having different monorepos for different Scrum teams if you're in larger organizations, etc. But I'm not going to go there for now. The other one is, as we already spoke, the projects and code in the monorepo are coupled together. There's no point in having completely arbitrary things put in the same monorepo, right? If you have two projects which are in no way related to each other, probably better to just have a separate monorepo for both of these projects. So those are the three main things that I've noticed, at least. Just it's more about collaboration, more about the size of how much code you're actually going to be writing, and also the size of the team. But you can always go through this reference if you want to go through a lot more about what other factors you may want to think about when you're working on whether to use a monorepo or not. The next thing, right? So this goes into whether to use polyrepos, monorepos. The next thing is about integrated versus package-based monorepos. For this part, I thought it's easier to try it out. So let's maybe just take a quick move to VS Code. So here I have a project. Can you guys see the font over here? Like last rows? Increase the size. Okay. Tough to fit. Is it better? Awesome. So I have a simple project over here, which has one repo called, or one folder called NX repo and one folder called plants repo. Now, plants is not, but you guys have realized that naming is really weird in the Python community in general. So these are two tools which are being used for monorepo management. There are actually many other tools. Again, a very good resource for this is something called monorepo.tools. It has a bunch of all the, like it talks about monorepos and so on and so forth, but then also describes all the different tools and different pros and cons of it. Let me just go to the nice comparison. Yep. So all the popular tools used for monorepo management and also various features that they have. You can even go into each feature and you can understand it a bit more, like there's a good description and so on and so forth. So again, monorepo.tools, good place to talk about the different tools that are being used for monorepo management. The two tools that I'm going to be talking about right now are NX and Pants. NX is actually a Node.js tool. It's not from the Python. By the way, quick note is that very few of these tools, like Pants is the only tool which is actually written in Python. Most of the other tools are either written in JavaScript because they have a very popular monorepo community, or Java, or some in C, like underlying C and then so on. So we're going to be talking about plants just mainly because that's a very cool tool written out in Python. So you can also contribute to it if you want to, and natively supports Python because of that. So it has a lot of good benefits for Python. And NX, which is a good all-rounding tool. I mean, yes, it's more meant for JavaScript, but it's pretty good for even other languages in general without too much plugin systems and so on. So these are two tools, the other two repos that I've created over here. Pants is the one that we're going to be talking about for integrated repos. Like Pants mainly supports integrated repos. NX can support both. And I've given an example which uses the package-based repos. Now, if I look at the code base in the integrated repo, actually, let me go through the package-based one first. So in the package-based one, I just written out a quick README and so on and so forth. But the basic thing that you'll see is that there's a folder called libs, which is the libraries that you have. Inside libs, you have different packages that you may want to work on. In my example, like data lake and reports are two packages that I've created. Data lake manages data, reports is creating fancy graphs on top of the data. The data lake and reports could have actually been two separate repositories if I was using a polyrepo setup. But I'm trying to move them into a monorepo. So I just have two different libraries called data lake and reports present over here. In the Pants example, on the other hand, I cannot easily place them as two different libraries. In an integrated repo, you just write out all your code as a single package or a set of packages. So you have a namespace called corridor and you just have different code bases under it, like different folders under it, data lake, reports, so on and so forth. And you just write out all your code. Now, what does that mean, right? Like that must be confusing to you guys. So data lake, as an example over here, has its own setup.py, pyproject.toml, and so on and so forth, right? It actually is a separate Python package, as a normal Python package definition. But in the integrated one, none of that stuff's there. It's just a single folder. It's just a module, as we call it in Python, right? It's just a folder with an init.py. It's just as simple as that. So what does this exactly mean? This means that in the package-based repo, each library is kind of an independent package. You can have a different testing framework, like you could use PyTest for one, you could use Nose for another, you could use Flake8 for one, you could use Black for another, and so on and so forth. They're all very decoupled projects. that are just kept together in the same folder for libs, which is in the same repo. But in the integrated one, it's actually just one large code base that you have created. Each file is considered as a separate project of its own. And the way Pants figures out the dependencies across projects, right? Because like in the package-based one, you normally just put it in your requirements.txt, like which different packages a package depends on. But in the Pants world, it actually goes through all the import statements that you have. It goes through the import statements and figure out, oh, okay, this guy is using corridor.data lake. So therefore, the reports package depends on the data lake package to get the data and so on. So the main thought process is in an integrated repo, every file, every py file that you're writing is considered a separate project. Whereas in a package-based one, you basically define it as every folder that you have and every folder which has a PyProject.toml or whatever folder you've created in your folder structure, right? So but like, let's just go into a bit more about what does that mean, right? The easiest way to actually understand this is is to just try running a few commands. But before I go there, a few notes. In NX, you have the nx.json, which talks about how you're structuring out your folder structure and so on and so forth. In Pants, you have a pants.toml, which again has some configuration for Pants to be able to use your monorepo well. Let me just put them side by side. Is it too zoomed in? Can you see it clearly? Seems fine. Yeah. Okay. So in Pants, if you're going to start off with Pants, what you can simply do is you just run /Pants. So what that means is in Pants, there is a binary file which is committed into your Git. It's called the Pants file. It has various things which will automatically download the Pants executable for you and then just start working on things from there. Right? So let's say if I'm taking the Pants repo over here, and I'm just running Pants help goals. It is automatically installed Pants for me. It's able to get the help command from Pants and just showing me some bunch of information. In NX, it's not as simple in the sense that there's just one extra command to run. So there's an npm install to install NX itself. Remember, NX is a Node.js command. So you need to run an npm install. That's fine. It's already installed. And then you can run NX commands using the NX ---- help. Right? So you can get all the instructions about how to run NX commands and so on and so forth. You can also go in and then say, all right, in Pants, I want to lint on something called : What does that mean? That just means that Pants is going to go in and lint all the packages that we have created in Pants. In this case, I just have like 4, like the histogram, data lake, and a few others. So I'm just going to go in and lint using flake8, isort, black, all the packages that are present in Pants. I can even do this using globs. So I can even use the ** format. So you can even just say corridor/**, which will just get all the files in the corridor folder. You can do similar kinds of things in NX. So in NX, the equivalent command will be nx run many target lint. But again, a quick note over here is that it doesn't, like, you cannot directly run a lint because in NX, you need to separately install your packages one by one. So the difference over here is that in Pants, you normally talk about a workflow. When you say lint, it automatically recognizes that to be able to lint something, you need to install it first. Like you need to install flake8, black, and so on and so forth first, and it handles all of that stuff for you automatically. But NX does not do that. It's just running simple commands for you. So you need to tell it first, install everything for me, then lint everything for me, right? And the lint will again do, let me take a look at that. So the lint will actually run it on the 2 packages that we have and just give us the results from that. Again, it's running black, flake8, and all the other things for you internally. Now, a quick note over here is that there's a lot of stuff that goes on under the hood. So there's a lot of parallelism, as an example. Over here, it is actually running isort or black Flakate in parallel to each other. It's not like you're running them one after the other. This is running like, let's say Flakate as an example is not a multiprocessing setup by default. So it only runs on one CPU, right? Black also runs only on a single CPU. So therefore, it actually just takes one CPU, runs it for you, one CPU runs it for you, and runs them all in parallel. So it's actually pretty fast. And it also does it across projects. So it can run Flakate for data lake and Flakate for reports in parallel on two CPUs. Pans does the same thing, but it actually does it at a PY file level. So while over here, I'll be, let's say if I'm running Black, PySort, and Flakate, and I'm running it on two projects, right? So there'll be 6 concurrent processes running over there. In PANs, there'll actually be many more because it's, remember that for integrated packages is at a PY level, right? At a single file level. So for every file, which could be like 10 different files that I have over here, it'll actually be taking 3 into 10, 30 different processes could be running at the same time. So that's the kind of difference. Like in integrated repositories, you will see that things can be a lot faster because they're at a much more granular level. In package-based repositories, the most granular level is a package. So you can't go lower than that, right? Or the tools don't really handle things inside a package. So that's honestly the main difference between integrated versus package, right? The fact that a unit is a PY file versus a package in package-based. But this internally goes into many other things. Like for example, speed of execution is one of them. But the other one that all of these tools provides, which is pretty cool, is the concept of running on affected files. Because in your CI environments or even in your local environments, you don't want to keep on running a lint on all your projects, right? Let's say if I have 100 projects, I only change something in one of the projects. I don't want to run linters on all the 100 projects. So all of them have this pretty neat thing called, or NX has this thing called NX affected, which says run only the projects which have been changed since the main branch or the master branch, and run lint on those changed projects, right? So it finds changed projects and just runs lint on that. Pans has something similar. So you can just say pans changed since main and lint. So to just find all the files that have changed since main and lint them. The biggest problem that you'll have, right, like going, like we talked about the pros of integrated repositories and the kind of benefits it can give you. But the biggest negative of integrated repositories is the fact that you need to actually manage the dependencies at a file level. This is not a very typical process, right? Like when we are writing our code, we have different packages and you're just working on each package independently. But in Pants, you need to, like, let's say if I have a project which is using a CSV file, this cannot be automatically inferred using import statements and stuff like that, right? So I need to explicitly say that my code is using the home ownership.csv file. So a lot of these dependencies need to be correctly mapped out for PANs to work correctly. And that can get very bothersome or very different from the way that we normally work, right? So that's the main negative in terms of integrated. So just recapping, the good positive about integrated is that granularity is a file level. So you can actually do things much faster and caching and everything can happen at a file level. But the negative being that you need to now manage dependencies at a file level, which can get very painful very quickly, right? So that's the main core difference, and that just has many other differences that come along with it. Yeah, so just recapping, dependencies are at an import statement level. Over in package base is at a requirements file level. The tooling like Flakate and so on and so forth have to be same for all projects, but here you can use different Flakate or Black or something for different packages. Migrating projects is not as easy and integrated because it is a very different structure that you need to work with your dependency management and so on and so forth. And caching is at a file level, and over here is at a project level. Right. Right. That's about it for this talk. Do we have time for questions?
Yeah. So we have. So we have time for about 4 minutes. So any questions?
Hi, it was a very good presentation. So monorepos and polyrepos. So how does it completely support on modern CI/CD pipeline setups like with GitLab, with Azure AWS toolings, as well as GitHub workflows?
So all of these can be integrated with GitHub Actions or Azure or whatever you want to integrate with. Pants and NX and most tools have good integrations with them. So you can actually just say, run my Pants workflow and it'll just run it for you. Or run these commands in NX and it'll run it for you. But the affected part, right? The fact that you're only going to be running things which are affected helps your CI pipelines a lot. And there's also a layer of caching, the last part which I was just talking about, which is that if something is already run and the tool is sure that the outcome of that run command is not changed, then it'll just cache it for you. And you can tweak how the caching and so on and so forth happens so that it can run faster or at least as equivalent as a polyrepo setup.
Thank you.
Hi, Abdali. That was a great presentation. I just wanted to check one thing with you. Given that serverless architecture is getting a lot of fame of late, which one do you think is more preferable, monorepo or polyrepo?
Okay. So I don't think that has any relevance to monorepo versus polyrepo, like in the sense that if I just come back to this slide, the way that you're going to be deploying these and how the end user is going to be using them should not be dependent on how you're going to structure out your repos, right? So even if you're going to be deploying to a Lambda or a serverless setup, you still need to package your code. I'm assuming we're not putting Git repos into stuff, right? So we should still ideally be having a packaging process, which packages into different things. Like you can have a plex file, a wheel file, or something else, or even zip files. And then that goes into ideally an artifact tree or wherever you're keeping your production artifacts, which then gets deployed to serverless. So in my mind, the way that you structure your repos should not impact the way that you're going to deploy them, because you have the abstraction layer of how you're going to package them. And your packaging is completely independent from Monorepo, right? Monorepo does not imply you have a single package. You can have many packages in both setups. We're done? Awesome. All right, thanks a lot. If you have any more questions, you can feel free to reach out to me anytime today.
Thank you so much, Ali. Ali, can you please come and get your gift? Thank you. So guys, an announcement that tea and coffee has been